Algebra 2, Chapter 5, Section 6, Fundamental Theorem of Algebra. So, um, Fundamental Theorem of Algebra went based off of looking off an observation. So here we have three scenarios. Scenario number one, we have a parabola and it crosses the x-axis 2 times. So we have two what they call real roots, right? We have real and complex numbers. Complex numbers are imaginary numbers. So we have two real roots. Here we have one real root. The parabola hits the x-axis one time, and here this doesn't hit it at all. And we have 0 real roots. So one would believe, okay, there's only 2 roots here, there's only 1 root here, and there's only 0 roots here. There's no roots at all. But that's not the case. In actuality, there are still 2 roots for all three cases. The first case we saw, it crosses the x-axis 2 times, so we know that there are 2 real roots. There's the solutions to those 2 real roots. The second scenario, it crosses the x-axis 1 time, however, it has the same root twice, meaning it has a multiplicity of 2. So it still has 2 roots, it's just one number being used 2 times with a multiplicity of 2. So it's still 2 roots. And the last scenario was a complex root, meaning that it had imaginary numbers. And those imaginary 2 complex numbers are twofold, so it still had 2 roots, but it had 2 complex roots. So every one of those guys, all 3 of those scenarios, had 2 roots. And the reason being is because it was a quadrilateral, right? Plus blah, 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 blah. So since the degree is 2, it's going to have 2 roots. Whether it's 2 real roots or 1 real multiplicity of 2, or 1 root, 1 complex root, which is not possible, or 2 complex roots. If it has a degree of 3, it's going to have 3 roots, always. If it has a degree of 4, it's going to have 4 roots in whatever combination there is. Which leads us to the fundamental theorem of algebra, which says that if I have a polynomial with a degree of n greater than or equal to 1, then it has exactly n roots, including multiple and complex roots, just like I said before. Quadrilateral has 2 roots because it has a degree of 2. A cubic function has 3 roots because it has a degree of 3. Quartic function has 4 roots because it has a degree of 4. Quintic function has 5 roots because it has a degree of 5, so on and so forth. So, there's a couple of ways to do it, to find out all the roots. We've already done all the ways of doing it, so this is a culmination of all the stuff we've done so far. The first way of finding all the roots is to use the rational root theorem, which is to sort of guess and check. So let's do one here. We have x to the 4th times, or plus rather, x to the 4th plus 2x to the 3rd. I'm going to subtract 13x squared from both sides, minus 13x squared plus 10x equals 0. Since it's the highest degree of this polynomial is x to the 4, I know I'm going to have at least 4 roots. I'm going to have at least 4 roots. No, and at least I will have 4 roots. So we're going to use the rational root theorem and sort of guess and check. There's a 1 in front of here, so we can look at all the possible roots to 1. It's plus and minus 1. Then we have a 10 here, and we need to put all the possible factors of 10, which is plus and minus 1, plus and minus 2, plus and minus 5, plus and minus 10. Those are all the different ways to make 10. Remember we do P over Q, where this is the Q, P, and that's the Q, so it would be, plus and minus 1 over 1, which is 1, plus and minus 2, and I'll go all the way down the line. I did it for you in terms of finding the first root anyway. And I found that one of the roots is 1. So what we're going to do is we're going to plug in 1 for x. So we're going to have 1 to the 4th plus 2, 1 to the 3rd minus 13 times 1 plus 10. And that does equal 0. So 1 is a root. Since 1 is a root, and it's a positive 1, it's going to be in the form of x minus 1. Okay. Step 1, we found a root. Hallelujah. Step number 2, we're going to divide. We're going to use synthetic division. So we're going to put a 1 up here. We're going to divide by that number. The coefficient in front of x to the 4th is 1. The coefficient here is 2. The coefficient here is negative 13. And the coefficient here is 10. We drop the 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. 3 plus negative 13 is negative 10. 1 times negative 10 is negative 10. Negative 10 plus 10 is 0. So when I write this down in standard form, it's going to be x. We come from x to the 4th, right? X to the 3rd plus 2x squared minus, plus 3x squared minus 10x. So what do I notice here? I notice that this has an x, that has x squared, that has x cubed. I can factor out an x. Which means that I can write it as x times x squared plus 3x minus 10. So what do I have? I have x times x minus 1, the first one that I came up with up here. I use synthetic division, and I have over here x squared plus 3x minus 10. Alright, so I'm almost done. I have this here, I have this here, and I just have to factor this quadratic. And there's a lot of ways to do it. We've done all different ways of factoring quadratics. Here, am I able to use diamond method? Two numbers, that gives me negative 10. When I add them, gives me 5. I think I can. So this would be x plus 5 and x minus 2. X plus 5. So 5 times negative 2 is negative 10, and then 5 plus negative 2 is positive 3, so that works. So when I set this up, we have x times x minus 1 times x plus 5 times x minus 2. I set that all equal to 0, and I get all the roots. I have a degree of 4, and I have 4 roots. So when I put them all together, my roots are 0, 1, negative 5, and 2. 0, 1, negative 5, and 2. Okay? Those are my roots. This would be my answer. Again, using all the things that we've worked on in this section. Rational root theorem, polynomial division, factoring, and different techniques of factoring. So we can use diamond method. We can use, for different numbers, we can use, different scenarios, we can use completing a square, or we can use quadratic. Okay. Another thing that we've been using too also is graphing. We can graph it to find roots as well. So this scenario here, for number 2, they give me 2x to the 4th minus 3x to the 3rd minus x minus 6. We have to find all the roots. Well, we have x to the 4th, so it has the highest degree is 4. So I know I'm going to have 4 roots. I can do like I did before and do the rational root theorem and guess and check until I find what I'm looking for, or I can graph. And looky here, I already did a graph for you. And I have 2 roots. I have a root of negative 1, and I have a root of 2. So I have a root of negative 1, so I graphed. And I found a root of negative 1 and of 2. So if I have a root of negative 1, the linear root is going to look like this, x plus 1, right? And this is going to be x minus 2. And the reason why this is x plus 1 is because this is going to be x minus negative 1. Alright, so we found our roots. Nice. Step 1. Step 2. We're going to use synthetic division again. Notice there's no x squared component right here, so we would write 0x squared because we have to write every polynomial, so we'll use a 0 coefficient. We're going to divide by both of these. So we're going to divide by minus 1, and then we're going to divide by 2 afterwards. So I'm going to put a negative 1 here. This is going to be a 2. This is going to be a negative 3. Then we have a 0. We have a negative 1 and a negative 6. Let's do it. Drop to 2. Negative 1 times 2 is negative 2. This is adding up, so this is negative 5. Negative 5 times negative 1 is 5. 5 plus 0 is 5. 5 times negative 5 times negative 1 times 5 is negative 5. Negative 5 plus negative 1 is negative 6. And then negative 1 times negative 6 is 6. 6 plus negative 6 is 0. Which means this is going to be x to the 3rd 5x squared But once we do this, we do synthetic division again, and we use those same coefficients that we just arrived to. So this would be by 2. And this would be 2, negative 5, 5, negative 6, drop to 2. 2 times 2 is 4. 4 negative 5 is negative 1. Negative 2 times negative 1 is negative 2. 5 and negative 2 is 3. 2 times 3 is 6. 6 and negative 6 is 0. So that this equation is going to be, so we did it twice, right? So this is now squared. 2x squared, right, because this was cubed. 2x squared minus x plus 3. Okay. So now our factoring now has given us x plus 1 times x minus 2 times 2x squared minus x plus 3. And I have to think of a number that when I multiply it gives me 6, and when I add it gives me negative 1. I can't think of one. Does not occur. So there's two ways to do this. I could either complete the square to find it, or I can use the quadratic. And in this case, I will use the quadratic. And the quadratic, if you remember, is negative b plus or minus b squared take away 4ac root over 2a. So in this case, it's going to be negative 1 plus or minus negative b squared, negative 1 squared take away 4 times 2 times 3 square root over 2 times 2. That gives me 1 plus or minus 1 minus 24 square root over 4. And that gives me 1 plus or minus I. Well, actually, go over here. 1 plus or minus negative 23 over 4. Which gives me 1 plus or minus I square root 23 over 4. So this is two roots, right? This is 1 plus I root 23 over 4. And this is 1 minus I root 23 over 4. So we have four roots, right? We have x minus 1. We have we have 1, negative, we have negative 1, we have 2, and then we have my two complex roots. So when I write down what all the roots are, my roots are negative 1, 2, and 1 plus or minus I root 23 over 4. These are all my four roots. So I graphed it using my graphing device. I used synthetic division after I found the two roots, and I divided by those two roots that I found by graphing the two real roots. After I did that, then the remaining polynomial couldn't be factored using diamond method, so I used the quadratic to find the two complex roots, which is 1 plus I root 23 over 4 and 1 minus I root 23 over 4. Okay. That is essentially what this section is. all the different ways to find roots using fundamental theorem algebra. There are equivalent ways to use this fundamental theorem algebra. The main way that we've been talking about is that every polynomial with the root degree of n has n number roots. So if it's the highest root is a degree of 4, x to the 4th, then we have 4 roots, whether it's 4 real roots or a combination of multiple roots, imaginary roots, and real roots, or only imaginary or only real. There's multitude of ways. And the other 2 points, just point that out. Those are just different ways of saying the same thing. Every polynomial has n linear factors, meaning we can break them out into these factors right here. This is a linear factor, this is a linear factor, and this is we break this down to this linear factor. It's a linear factor, but it's just a complex linear factor. And if I was to write this as a linear factor, it would be x minus 1 plus I root 23 over 4. This would be considered a factor, and then the other factor would be minus. So you could write that in a factored linear form, which is what they're talking about here. And then it says every polynomial degree has at least one complex root. We could turn any root into a complex real root into a complex root if we wanted to. So that is also true. All right, that is that section. Hope you have a great rest of your day.